Welcome to Explore and Discover Curious World, the channel where space curiosities are never too strange, and improbable theories become conversation starters. Today, we're tackling an epic question: could life exist on distant planets, perhaps hidden beneath thick layers of ice or immersed in alien oceans? Spoiler, maybe yes, but don't expect the usual green aliens with antennas. If you're ready to dive into a sea of hydrogen and quirky theories, fasten your gravitational seatbelts and let's go. The classic vision: Earth as the model. When we imagine a habitable planet, we tend to think of an Earth twin, rocky, liquid water on the surface, a breathable atmosphere, and maybe temperatures that don't freeze you as soon as you step outside. Scientists, however, with their incurable optimism, are revising the concept of habitability and have started studying worlds that, at least on paper, seem to come straight out of a science fiction writer's imagination. Spoiler, it's no longer necessary to be in the famous habitable zone to have a chance of hosting life. Mars and Venus, for instance, are technically in the habitable zone, but one is a freezer, and the other is a toxic sauna. So, where should we look? In the past, scientists believed that only planets with conditions very similar to Earth could host life. However, in recent decades, we've begun discovering terrestrial organisms that defy our expectations: microbes thriving in boiling geysers, bacteria living without oxygen, and creatures surviving in the ocean depths without ever seeing sunlight. This has taught us a fundamental lesson: life, if it can, will find a way to adapt. And now, here's the key question: if life on Earth can thrive in extreme conditions, why couldn't it also do so on planets that seem hostile to us? This is where the idea of Hycean worlds comes in, a whole new category that's revolutionizing the way we view the universe. Hycean worlds, a name, a promise, and here's the most intriguing novelty: Hycean worlds, a name that immediately conjures up images of an icy smoothie and a Jules Verne novel. But what exactly are they? These are planets with hydrogen-rich atmospheres and vast oceans, hundreds of kilometers deep. Here's the interesting part: these planets could maintain habitable conditions even if they're far outside the traditional habitable zone. Hydrogen, in fact, acts as a super greenhouse effect, keeping moderate temperatures even at sidereal distances from their star. Basically, they're an astrobiologist's forbidden dream. Imagine a world where the surface is entirely covered by endless oceans, so deep that the Titanic would seem to have sunk in a puddle. Astrobiologists love these planets for one simple reason: they're proof that habitability could be far more common than we've ever thought. After all, who decided that life must follow the Earth's model? These worlds are a cross between gas giants like Neptune and terrestrial planets like ours. They're often 2 or 3 times larger than Earth, with dense and chemically diverse atmospheres. Such an environment might seem hostile, but for certain types of extreme life, it could be paradise. And here's the kicker: their hydrogen-rich atmospheres could act as giant thermal blankets, capable of maintaining favorable conditions for billions of years. Practically every extremophile's dream. Another fascinating detail is that the oceans on these planets could be incredibly deep, reaching hundreds, if not thousands, of kilometers. And here's the burning question: what could live at such depths where the pressure is so extreme it would crush a terrestrial submarine like an empty soda can? Scientists hypothesize that life on these worlds could be vastly different from ours, with organisms relying on chemical energy rather than sunlight. A concrete example: K2-18b. One of the most famous Hycean worlds is K2-18b, discovered in 2015. It's located just 124 light-years away from us, practically around the corner, cosmically speaking, and orbits a red dwarf star in the Leo constellation. This giant is about 3 times larger than Earth, with a mass 8 times greater and, drumroll, signs of water vapor in its atmosphere. Before you start dreaming of snorkeling on K2-18b, know that the presence of water is just a hypothesis based on theoretical models. But hey, that's already something. What makes K2-18b special is its combination of characteristics. Not only does it have a dense hydrogen atmosphere, but also temperatures that could allow for liquid water. And where there's water, at least on Earth, there's life. This planet has become a symbol of the new frontier in the search for habitable worlds. But let's not forget that K2-18b isn't an isolated case. There are over a dozen candidates that could fall into the Hycean category. And with instruments like the James Webb Telescope, we're just at the beginning of this thrilling hunt. The chemistry that fuels DREAM's recent observations with the James Webb Space Telescope have detected methane and carbon dioxide in K2-18b's atmosphere. And, drumroll again, traces of dimethyl sulfide, a molecule that here on Earth is produced by phytoplankton. Of course, before declaring we found our new cosmic neighbors, scientists remind us that further observations are needed. But it's an exciting step forward, especially considering that just a few years ago, we didn't even have the tools to analyze such distant atmospheres. Dimethyl sulfide could be a biosignature, but caution, it's not definitive proof. Scientists are excited, but cautious. After all, it took centuries to figure out we weren't the center of the universe. Maybe we'll have to wait a little longer for definitive answers about these alien worlds. But why is dimethyl sulfide so interesting? Because on Earth, it's mainly produced by living organisms, particularly oceanic phytoplankton. This makes its presence in an alien atmosphere a potential clue of biological activity. However, there are non-biological alternatives that could explain its origin. This is why science takes time. Every clue must be verified and re-verified. Beyond dimethyl sulfide, scientists are searching for other possible biosignatures, such as ammonia or complex organic compounds. These markers could give us further hints about the potential for life. And let's not forget that Hycean chemistry might be vastly different from Earth's, with entirely alien biological processes. And what about life? Could there be life on K2-18b or other Hycean worlds? Well, don't expect to find advanced civilizations or aliens broadcasting TikTok videos across the cosmos. The life we imagine on these worlds would likely resemble what we find in Earth's ocean depths, extremophile microorganisms that feed on chemical energy rather than sunlight. In short, an alien version of our plankton. And what if there were intelligent life? The probability is low, but the mere thought is fascinating. These worlds could host forms of life we can't even imagine, with biological and chemical structures completely different from ours. Maybe one day, with even more advanced technologies, we'll be able to confirm or refute these hypotheses. Just think about it, every time we look at the night sky, we might be staring directly at worlds teeming with life. Until then, let's keep exploring and dreaming of what might lie beyond. Who knows? The next great discovery could be just around the corner.